Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken and his brother Joel Chaiken. Today we have an amazing treat. One person actually emailed us at satmathquestionoftheday@gmail.com with an SAT math question that he was stumped on, and he said his friends are stumped on too. He says it comes from the October test from 2022, and now we're in November 2022. I don't know where he got it from, but I do know that there's a way to actually see the SAT you actually took by paying a few extra dollars and getting the question and answer service on your SAT. So that may be how he got it. But this certainly looks like a legitimate SAT math question. And Seth was gracious enough to let me try this as fast as I can. I've looked at the problem. I've never digested it. So here we go. And if you probably the best thing you can do is to pause this video for a second, try it yourself, and come back when you've tried it. Okay, here we go. Now I'm going to try to do this live. You've never seen it before, as fast as possible. Two numbers, A and B, are each greater than 0, and 4 times the square root of A. 4 times the square root of A is equal to 9 times the square root of B. Okay, if A is
hold on. 9 times the cube root of B.
You can't interrupt me.
You said the square root of B. You wrote the right thing, but
okay, but
said the wrong thing.
But I have it right?
Yeah.
Okay, fine. Okay. Now, if A is 2/3, so 4 times the square root of 2/3. Okay, A is 2/3, right? A is 2/3. Fine. Now, for what value of X is A of X 2/3 of X equal to B? Well, okay, fine. I'm not gonna do this brilliantly. I'm just gonna get this done as fast as possible. If we could solve for B, we know what B is because we could solve for B in the first equation. Whiteboard froze in a very bad way. Thank God pencils don't freeze when you're actually writing them. Come on, 6 seconds. I mean, come on. Okay, fine. So we can solve for B in this equation because we know A. I'm planning this out. And once we know B, then we can solve for X. Okay, so let's just do it. There may be a brilliant way to do it, but I'm not going to do it that way. At least at first. Okay, so 4 times the square root of 2/3 is equal to 9 times the square root of B. So that means that, oh God. Okay, I'm going to go up here. 4 over 9 times 2/3 times the square root of 2/3 is equal to the cube root of B. So what we're going to do is we're going to cube both sides. So 4/9 cubed times 2. And now I'm going to go to fractional exponents. I hope people know what I'm doing. 3 over 2. Because the square root of 2 over 3 is 2 over 3 to the 1/2 power. And when you cube it, you get a 3 over 2 thing. Now, again, Whiteboard froze. This is so embarrassing. And Seth's right. I got to go to a smaller type, and a thinner line. So you see what I'm doing? See what I'm doing there? Okay. Right? So now, this is a mess, right? This is a mess, but that's how... Seth, please. Okay, so this
Should I do it?
No, Seth, I said I'm going to know. I'm going to do it.
Oh,
I'm going to do it. I know it's painful to watch, right? So
yes,
math is painful. So this is B. Okay? Now, we have 4/9 cubed times 2 over 3 to the 3 over 2 power is equal to B. And this is, hold on. Wait, I'm getting lost. Hold on. What am I doing? This is 2/3 to the X power is equal to B. B is equal to 4/9 cubed to the 2/3 to the 3/2 power. Okay? Now, what I'm going to do is I'm going to take that 4 and a 9 and turn it into 2's and 3's. Wish I could erase, but I can't. So, 2/3 to the X power. Now, this 4 is 2 squared. So that's 2 squared to the 2 squared. That 3 Now, that 9 is 3 squared. Okay? And that's all to the cube power. Times 2 over 3 to the 3 halves power. So, what have I got here? I've got 2 to the 8th divided by 3 to the 6th, right? Because this is the power rule. No, it's 2 to the 6th. Sorry, it's 2 to the 6th. 2 to the 6th, right? 2 times 3, 2 to the 6th, and then 3 to the 6th. Okay. So the answer is going to be 6.5. Right? We already see the answer is going to be 6.5. No, 7.5. 7.5. 7.5. I shouldn't cut corners. It's 7.5. Hold on, Sideboard froze again. Well, this gives you time to sort of digest what's going on. Sideboard is really not behaving today. I don't know what is going on. So anyway, this is this, and this is 2/3 to the 3 halves. See, if I cut quarters at the end, I would have gotten it wrong. So this is 6, and notice the commons, see, 2 and 2, 3 and 3. That's really nice. So that we just we use the product rule for exponents. 6 plus 1.5 is 7.5. X is, for what value of X? X is 7.5. That was really painful. Seth, I know you were dying, right? You were going nuts.
No, it's okay. It's okay.
So now let's calmly. Now I hope the people who said this email that said none of their friends could get it. So I hope, I don't know, maybe should we neaten it up a little? Maybe erase everything and do it more neatly. Or Seth, do you want to do? Is there a faster way to do this thing? Have you noticed?
No, I think the wise move is to, keep 2/3, keep the base 2/3 of exponentiation unchanged, and then recognize that 4/9 is 2/3 squared. And so do everything in terms of powers of 2/3.
Right.
And then you come to the equation, 2/3 to the x equals 2/3 to the 7.5. And since in this region of functions, exponentiation is a nice invertible function, then x is equal to 7.5.
Right. Yeah. So
if you separated the 2 and the 3 in the exponent, that would lead you to extra work, because you'll have to put them back together.
Now you almost have to use fractional exponents, don't you? Here. You almost have to say the square root of 2/3. You really do have to say that the square root of 2/3 is equal to 2/3 to the half. If you don't know that as a technique, a method, you don't know that as a way to express the square root of 2/3, you got a big problem here.
Yeah. Right? The one piece of extra writing that you could have avoided was going from 4/9 to 2 squared over 3 squared. You could simply get 4/9 equals 2/3 squared.
Right. Yeah. Notice I got sort of lost here. Did you notice that? I lost myself. I was here. Like, what? I lost myself, but I caught it. I caught it, right? So this is the type of problem. I don't know how long it took me to do. We could go back and see, but this is the type of problem you want to do the other questions quickly on, so that you have time to do this.
Well, this is a question where it helps to carefully do algebra by following your nose.
Yeah, right.
Write the facts that the problem gives you in algebraic form. Simplify the composition of facts and you just follow your nose, and it leads you to the next to last equation that tells you the next to last equation is, x 2/3
Right.
raised to the x power equals 2/3 raised to the 7
7 and a half.
and 1/2 power.
Right. 3.
And of course, the 7.5 comes from 6 plus 3/2.
Right. Yeah, I made a mistake there when I said a half. I hopefully
Yeah.
would have caught that. Did you notice though that be psychologically to make sure that I was sure to have the right track? Did you notice that I first did an analysis of what I know, what I don't know, what I know, and how I'm going to get it? Right. I wrote this down. But this is really important, so I'll put it in thicker green. I hope you don't mind, Seth. Is this whole little analysis that I did? Do you see that when I started the problem?
Yeah,
where I first said, I need to solve for X. If I know B, see the little check mark? If I know B, I can get X, and I can get B through this equation.
Yeah,
so this is
exactly, sure. So the facts. This is fact 1, which is expressed by equation 1,
right?
And let's see, and what's fact 2? And then A is 2/3. I guess that's fact 2.
Yeah.
And then finally, x A to the x is 2/3 to the x is equal to B. This equal corresponds to the use of equality symbol here.
Right.
Yeah.
Yeah. But it's really nice psychologically. Not only there are 2 reasons to do that. One, psychologically, you want to make sure you can get the answer, so you feel a little comfortable. You feel a little confident going through it, but also, frankly, you have to know how to do the problem, right? You have to plan out how to do the problem.
Yeah. I would have done it. I would have done this. I would have written 3 equations. I'd use the fractional form of square root right away. So I'd write 1/4 times A to the 1/2 equals 9. Try and make sure it really looks like a 9 times B to the 1/3. I left A there. A equals 2/3. And then A to the X equals B. And there's the B, there's the B. There's A, and it tells me what A is, and so then from this I would say, okay, we just take these two equations, replace the A by 2/3, and then we get we could then solve for X.
Right.
I wouldn't have so soon replaced A by 2/3 because we don't know until you get to here. We don't know what we're doing.
No, I planned.
But that's
okay.
But that's just as good. Yeah.
Okay.
Right.
I mean, we can go on and on and on about this.
That's it.
The key here is the fractional exponents, right? You have to follow your nose. You have to make sure you move into fractional exponents. Otherwise,
we use the rules. Rules about fractions and fractional exponents.
Yeah, you have to know.
Like P over Q to the R divided by S is equal to P to the R divided by S divided by Q to the R divided by S.
Yeah, there are 4 exponent rules you have to use here. There are 4 exponent rules.
There's a whole bunch of them.
So should we let's just really quickly out.
And the S root
Yeah, I know.
of
So,
P
great.
to the R is equal to P to the R divided
Seth,
by
Seth,
S.
I'm going to go to clean area. For
Yeah, that's all.
one, no, there are at least 4 exponent rules. First of all, you have to know x to the a times x to the b is x to the a plus b. How did that come in? That came in as x to the 6th. Oh, it's so annoying. X to the 6th times x to the 3/2 is equal to x to the 7.5. You had to know that x to the a to the bth power is x to the a times b. That came in as 3 squared cubed was 3 to the 6th. Okay, I'm just making that up, right? And then you had to know what Seth said. Oh, then you had to know that x to the, oh God, then you have to know the fractional exponent rule. This is really, really bad how this thing's freezing. You have to know the fractional exponent rule. The x to the 1 over a is the 8th root of x. X to the 1 over a is the 8th root of x. We use that by knowing that 2 to the 1/3, 2, the cube root of x is equal to x to the 1/3. And then we have to know the rule Seth said last, right? X to the, what was it? X to the a, x to the xy to the a.
X divided by y.
Okay, x over y a is equal to x to
X
the
over
a.
y to the 8th power.
Yeah, x over y to the 8th power is x over x to the 8th power, y to the b, y to the 8th
divided
power.
by y to the 8th power.
I know, and that's equal to x over y to the 8th power. So you may have to go both ways on this one.
Yeah.
Okay.
You know, when you read the algebra, don't do like my brother does and skip saying the names of the operations. X over a is not xa.
Okay.
Right. X over y is not xy.
Right. No, yeah, that's right.
It's x divided by y.
That's right. But anyway, the bottom line is, believe it or not, I think you actually had to know. I think all 4 of these rules came in this problem.
Yeah.
So those are them. Those are the exponent rules. And the only one we left off that you should know is x to the a divided by x to the b is x to the a minus b. Okay? But you don't really have to memorize that, because you can write x to the a, x to the minus b, right? Because this is that, x to the that one. That, something's downstairs, the negative exponent flips it, and then you use the product rule, x to the a minus b. Oh yeah, so let's, just for completeness, let's do that one. X to the negative a is 1 over x to the a. Believe it or not, I don't think we use that one in this rule, in this game. So, okay. And then x to the 1 over x to the minus a is equal to x to the a. So there you go. All the exponent rules laid out. That's it. Okay. So, I guess we're done, right?
Yeah, we're done. That was that.
Well, thank you so much for the person who sent this question to us. We don't know how you got it, but our job is not to ask questions. Our job is to answer questions. We're not going to ask where you got that from, but you probably got it from the test, from the question and answer service from the SAT. Okay, everyone, have a great day. Thanks, Seth. Thanks for...
Okay, bye. Thanks, y'all. See you later. Bye.
Keep sending your question. Bye-bye.